We will solve inequalities and equations in this lesson. An equation is a statement that two expressions are equal, like x equals 5, y minus 6 equals 2, 3k equals 9. Whether these equations are true or not depends on what the x or the y or the k has for a value. So an equation has to have an equal sign. There has to be something equal to something else. An inequality, on the other hand, is a statement that two expressions are not equal. Symbols that show not equal could be the greater than sign, like 8 is greater than 2, or 9 is greater than x plus 4. Again, whether this is true depends on what value you give x. 3p plus 2 is less than p minus 1, or 5 is not equal to 3. To make any of these true, I simply have to pick an x that would make it true. This one, you don't have a variable, so either 8 is greater than 2 or it's not. This one happens to be true. On this one, if I put 1 in for 4, then 1 plus 4 is 5, and 9 is greater than 5, so putting 1 in would make it true. But if I put 10 in here, 10 plus 4 is 14, and 9 is not greater than 14, so then it would be false. In this problem, we want to know if 3y is less than, greater than, or equal to 18 when y equals 6. So I'm going to substitute 6 in for y here, remembering that 3y means 3 times 6, which is 18. 18 happens to be equal to 18, so I fill in the blank with equal. What about the same expression, but when y equals 10? Well, substituting 10 for y gives me 3 times 10, which is 30, and 30 is greater than 18. And finally, when y equals 5, 3 times 5 is 15, so 15 is less than 18. Pause the video and decide what should go in the blank: less than, greater than, or equal to, given the value of the variables. In the first one, if I make b equal to 8, then 4 times 8 is 32. 32 minus 6 is 26, so 26 is equal to 26. In the second one, 3 times 15 is 45, and 45 divided by 5 is 9. On the right side, I substitute 15 and take away 8, and I get 7. So the 9 that I have and the 7 that I have, the 9 is greater than the 7. And then the last one, substituting 9, 8 times 9 is 72. 72 minus 4 is 68. On the other side, 6 times 9 is 54. 54 plus 10 is 64. So my 68 is greater than my 64. Now we are going to start solving an equation for the variable. For example, in this one, we want to find out what a is to make this equation true. Well, this doesn't really look like an equation except that I have a balance here. And so it's like a teeter-totter. And both sides have to be the same when it's an equal sign. So I can think of this little middle here as my equal sign. Whatever is on the left side is the same weight or is equal to what's on the right side. And so if I want to keep this balanced, then equality properties say I can add the same number or subtract the same number or multiply the same number or divide by the same number on both sides, and my balance will stay equal. Well, it looks like I can take 2 off of both sides. That would leave me with a on the left side, because I took 2 away, and taking 2 away from 5 leaves me with 3. So my resulting equation says a equals 3, or there would be a weight of 3 or 3 counters in here to equal these 3 counters or 3 digits over here. my original equation at the top would have said this A plus 2 more equals 5. Once I took the 2 off of both sides, I ended up with A equaling 3. Well, if I take 3 plus 2, that does give me 5, so that makes sense. In this one, I have 4A boxes over here, and I don't know how much is in each box, but I know I have 8 over here. So if these are supposed to stay equal, of these 8, I need to split them into 4 different groups. So I need to take 8 divided by 4. That must mean that my A is going to equal 2. So on this one, I divided 8 by 4, and I divided this 4A by 4, and that left me with 1A in each group. That was worth 2 in each group on this side. My original equation up here would have said 4A equals 8. And so I divided both sides by 4 to get A equals 2. Another way to think about this is if I started with A here in my circle, and then I had 4 A's, so I take it times 4, that had a balance or equal weight of 8. So 8 would go in here. To find out how much each one is worth, I could undo it going this way. If this is times 4, the inverse of multiplying, or the opposite, is to divide. So when I want to solve it, I will undo the multiplication by dividing. So if A times 4, or 4A, equals 8, then going this way, 8 divided by 4, means each A is worth 2. So A equals 2 is still my answer. In this one, on the left side over here, I have 6 letter P's. So that would be 6 times P, and then I have an extra 7 here, so plus 7, and then here's my middle, my balance, has to equal 37. Okay. With the loops, I would start off with my circle and call that my variable, P. I don't know what that is, but I know the first thing that happened was it was taken times 6. So I'm going to write times 6 here. And that gives me something. And the next thing I do is take and add 7. So I'm going to add 7. And I see that that would give me 37. So I put my answer of 37 in here. To undo this one, both sides have an extra 7 I don't need. So I'm going to take that 7 off of there. If I take 7 off of there, they're gone. And if I take 7 off of here, I'm left with 30. That was my first step here, 37. Undoing add is subtracting. So if I added 7, subtracting 7, that gives me 30. Well, now I have 30, that's worth 6 boxes. So I can split that 30 into 6 boxes. That would be doing the opposite of multiplying. Instead of multiplying by 6, I'm going to divide by 6. And 30 divided by 6 would put 5 in each box. So if I divided by 6, divided by 6, I would get 1 variable P is equal to 6, which, is 35 by 6, is 5, not 6. And that's what I got over here too, is P equals 5. Let's look at that one more way. If this is my original equation, then this is like my balance, and my equals is my little teeter-totter. And so order of operations says 6 times P first, then plus 7 equals 37. When I undo backwards. I'm going to undo my 7 first, so I'm going to take away 7 first from both sides. And then on this side I'm left with 6 p's, and on the other side I'm left with 30. Well, this is 6 times p equals 30, so I'm going to undo that by dividing both sides by 6. That will leave me each triangle of p is going to be equal to 5. That's another way to show your work and find the answer. Undo the equation. Instead of multiplying and adding, we undo them backwards. We undo the adding with subtracting and undo the multiplying with dividing. You pause the video and try to solve this equation. What value of r will make 5 times r plus 5 equal to 60? You can use this side to solve it, or you can use the circles that I set up to help you. R times 5 plus 5 equals 60. Undo it. On this side over here, to undo the plus 5, because it was 5 times r plus 5, so I'm going to undo the plus 5 first by subtracting 5. That leaves me on this side with 5r, and on the other side with 55. Since this is 5 times r, I undo times with divide. So to keep it equal, I have to divide both sides by 5. So r is going to equal 55 divided by 5, which is 11. In the circles over here, r times 5 plus 5 equals 60. So going backwards, I'm going to subtract 5 first. That gives me 55. And then I'm going to divide by 5, which gives me 11. So I also get r equals 11 by doing the loops. I could also use the teeter-totter, or the balance again, and take off 5 from each side. So taking 5 off of here leaves me 55. And then I have 5 boxes over here on the left to split it between. So 55 split into 5 boxes is going to make each r be equal to 11.